Previously, we looked at using postulates to prove a theorem. So again, postulates are things that you accept are true, or something that you can see is true, and we can use those to then move on to something else, build those together to prove that something else is true. And when we prove that something is true, we call that a theorem. So we have a theorem that we're going to start with, and that's that all right angles are congruent. So this is a true statement. It may seem obviously true, but any right angle is congruent to any other right angle. So that's what we're going to look at trying to prove here in the first part of this lesson. So what we're given that angles 1 and 2 are right angles. So that's this angle and this angle here. Now what we're trying to prove is that angle 1 is congruent to angle 2. So you can see the steps here, the statements on the left side. Let's just go through those one by one, and then we'll fill in the reasons. So the first part, angles 1 and 2 are right angles. We were given that. Then it says that the measure of angle 1 is equal to 90, and that the measure of angle 2 is also equal to 90. So we know that this is true because both of the angles together, they must equal, both of the angles separately, they must equal 90 degrees because they're each right angles. Well, if angle 1 and angle 2 are both equal to 90, that means that they must be equal to each other. So the transitive property tells us that if two things are equal to something else, then they must be equal to each other. And then the last part, once we know that the measures of the angles themselves are equal to each other, then we know that the angles must be equal to each other. So the objects must be the same if their measures are the same. So again, the reason for the first one is that we were given that this is true. Then for part 2, we know that the measures have to be equal to 90. That's just by the definition of right angles. And you'll see me using abbreviations here. So DEFN is an abbreviation for definition, and then of right angles. And I'll use the angle symbol instead of writing out the word angle. All right, then for step 3, the measure of angle 1 is equal to the measure of angle 2. Well, again, the measure of angle 1 is equal to 90, and the measure of angle 2 is equal to 90. Well, if those both are equal to 90, then they must be equal to each other, so we can use the transitive property for that. And I'll abbreviate property as PROP. Then for the last step, the angle 1 is congruent to angle 2. Well, we know that this is true because their measures are the same. So again, here where we have the M in front of the angle, that we're talking about the measures of the angles, how many degrees it is. And so if we know that they have the same number of degrees, then we know that the objects themselves must be the same. So again, we use equals for numbers and congruence for objects. So we can say by the definition of congruent angles, so again, I'll abbreviate definition as DEFN, and then I'll use the congruent symbol instead of writing out the word congruence, and the angle symbol instead of writing out the word angle. So the definition of congruent angles is that congruent angles have the same measure. So in step 3, we found that they have the same measure. So then in step 4, we can go from there and say that since they have the same measure, they must be the same. Now that we've proven that that's true, we can use that. So that's what we're going to do in example 1 here. We can use the fact that these two measures, that right angles are congruent to each other, the thing we just proved, we can use that fact in other proofs. So for example 1, we're told that segment AB is perpendicular to segment BC. So that gives us this right angle here. And then we're also told that segment DC is perpendicular to segment BC. That's this right angle right here. And so in our proof, that's given to us. So we start with the given statement. You always start with what it is that you're given. Now in step 2, it says that angles B and C are right angles. Well, if we look to the definition of perpendicular lines, what it means for lines to be perpendicular is that they meet at right angles. And if you were to flip back into your book, you would see that definition. So we can say that B and C must be right angles just by what it means to be perpendicular. So definition of perpendicular lines. And that symbol right there, that means perpendicular. So the upside down T, that means perpendicular. And for step 3, the last step, well, we can see what this is going to be in a couple different ways. First of all, it's the last step of the proof, and the last step of the proof is always what it is that you are trying to prove. So we're trying to prove that angle B is congruent to angle C. But we also need to have this follow from previous things in the proof. So step 2 says that angle B and angle C are right angles. Well, we just proved that right angles are congruent, so we can use that thing that we proved. So the thing that we just proved in the example before was called the right angles congruence theorem. So we can say that B and C must be congruent by the right angles congruence theorem. And again, I'll abbreviate angles with the angle symbol, congruence with the congruent symbol, and then not really a good abbreviation for theorem. All right, for 2.4 and 2.5, theorem 2.4 and 2.5, these are two theorems that we're going to use. Actually, in the last example here, we're going to prove one of them. So theorem 2.4 is called the congruent supplements theorem. Now what this says is that if we have two angles that are supplementary to the same angle, then they must be congruent to each other. This is almost like the transitive property. So the transitive property says, if A is equal to B, and then B is equal to C, then A and C, those must be the same because they're both equal to B. So this is similar to that, but a little bit different. So this says if one angle is supplementary to another angle, and then a third angle is supplementary to that same angle, then the first and third angles must be the same. I think this is easiest to see with actual numbers. So let's say that angle 2 is 150 degrees. Well, if angle 2 is 150 degrees, and angles 1 and 2 are supplementary, that means that angle 1 has to be 30 degrees. So if angles 1 and 2 are going to add up to 180, then and angle 2 is 150, then angle 1 has to be 30 degrees. Well, now let's ignore angle 1, and let's look at angles 2 and 3. So if angles 2 and 3 are supplementary, then angle 3 must be 30 degrees, because in order for the two angles to add up to 180, angle 3 has got to be 30. And then you can see that angle 1 and 3, well, they both have to be 30, so they have to be the same as each other. So then we can say that angle 1 must be congruent to angle 3. For theorem 2.5, we're going to do pretty much the exact same thing, except instead of having supplementary angles, we're going to have complementary angles. So this one is called the congruent complements theorem. And this one says that if 4 and 5 are complementary and 6 and 5 are complementary, then 4 must be congruent to 6. Again, let's look at this with some actual numbers. So let's say that angle 5 is equal to, say, 50 degrees. So if 4 and 5 are complementary, that means that angle 4 must be 40 degrees because they've got to add up to 90. Now ignore angle 4, let's look at angles 5 and 6. So if 5 and 6 are complementary, and angle 5 is 50, that means that angle 6 must be 40 because they've got to add up to 90. So 50 plus 40 is 90. Well, now you can see that angles 4 and 6 both have to be 40 degrees, and so that means that they must be the same as each other. All right, for the last piece here, we're going to look at proving the congruent supplements theorem. So we're going to prove that if two angles are supplementary to the same angle, then they must be congruent to each other. So let's start with what we're given. We're given that angles 1 and 2 are supplements, and we're given that angles 3 and 2 are supplements. Now you'll notice in the first statement that we have that angles 1 and 2 are supplements and that angles 3 and 2 are supplements. We have two statements in one statement, kind of combined together. And we can do this. This is perfectly fine. There's no problem with doing this as long as they have the same reason. So we know for step 1 that both of these things are true because they're both given to us. So since they have the same reason, we can just put them in the same spot. Step 2 also has two statements in the same statement. And again, we can do this because they have the same reason. So if angles 1 and 2 are supplementary, that means that they add up to 180 degrees. 3 and 2 are supplementary, so that means they add up to 180 degrees. So we know that both of these are true just by the definition of supplementary. So if two angles are supplementary, they add up to 180. So same reason for both of those. Now for step 3, again, what we're trying to do here, we're trying to show that 1 and 2 are the same. So let's see if we can find an equation that will equate those two. We can almost get there from step 2 using the transitive property. So if you look at the fact that 1 and 2 together equal 180 and that 3 and 2 together equal 180, well, both of these things equal 180. So we can take this and say that that's 180, and we can take this and say that that's 180. So if they both equal 180, then they must be equal to each other. So we can say that the measure of angle 1 plus the measure of angle 2 must be equal to the measure of angle 3 plus the measure of angle 2. Well, now we have an equation, and you can see that we've got the measure of angle 2 on both sides. Well, what we really want is the measure of angle 1 on one side and measure of angle 3 on the other side. We want these things to be the same. We want them to be equal. So if we just subtract the measure of angle 2 from both sides, well, then it'll cancel out here, and we'll get the measure of angle 1 on the left side, and it'll cancel out here, and we'll get the measure of angle 3 on the right side. And so now we have them equated. We can say that the measure of angle 1 is the same as the measure of angle 3. I fell behind in the reasons here, I guess. So for step 3, this is by the transitive property. And then how we know that we can subtract something from from both sides of the equation and also get a true and still get a true statement is the subtraction property. All right, now we're almost to the last statement. So we've shown that they are equal, that they have the same measure, and so that means that they've got to be congruent. So by the definition of congruent angles, if two angles have the same measure, that means that they are the same. They are congruent to each other. So we can say then that angle 1 is congruent to angle 3 because they have the same measure. And so by the definition of congruent angles, we can say that angle 1 is congruent to angle 3.